Is my screen visible, Monica? Okay, thank you. So, friends, I'm told that there was one session on GPS, and let me put things again in a review mode first. That as far as this idea of GPS is concerned, which is popularly known as a global positioning system. Now, this was basically an idea which was being introduced by the American Naval Forces, Navy. And it was way back in 1958, friends, that uh, American naval agencies they thought of developing a regional level GPS that is called as global positioning system. But in those days, it was not GPS; it was called as uh, Transit Navy Navigational Satellite System. I again repeat: the U.S. Navy developed a small system called as Transit Navy Navigational Satellite System way back in 1958. Now, what was the today, friends? It is very important for us to understand that as far as location is concerned, location is very important for us. We were locating ourselves in traditional mode using different kinds of traditional techniques. But then the most important question or the requirement of the scientific body was that while all traditional systems were giving us locations, but then the locations given by them were static. That means here is a mountain, here is a city, here is a building, here is a person, that's all. So it was possible to know the static location of different objects on the earth's surface. But then our requirement was increasing and we wanted to know the dynamic locations of the places. That means if a particular thing is moving and within half an hour if it has changed its position, then I must know the position in dynamic mode. So all the traditional systems which were already existing, none of them was able to address this issue of dynamic the movements. And American Navy had a problem, particularly in the Second World War, that their ships used to go in the Atlantic Ocean or in the Pacific Ocean on both east and west coast, and they were not having any idea where the ships are right now and how far they are from the coast, where they are moving, in which direction they are going, how much time they will take to reach the coast. And therefore, these were the issues, and therefore, they thought of managing their boats, steamers, warships with the help of the regional system in which they had just 5 satellites. So, they placed those 5 satellites on their space at a height of about 1075 kilometer. So these 5 satellites were placed all over the USA, and from there they were trying to communicate. They were trying to find out the locations of the different ships. That was the traditional mode. But then later on, it was found that the application of those 5 satellites was very useful. But then slowly USA expanded its territory and territorial control over the whole world. So there was a realization that it is not only Navy which is going to use this information, even the Air Force can use this information, even the land forces can use this information. So all of them, even the mariners, they wanted to use this information. And therefore, way back in 1973, friends, it was decided that the American forces, particularly the Department of Defense, the DoD, will have a system for the whole world. And they came out with a system. So this transit NNSS was replaced by a new system which is called as Nav Star GPS. Nav Star GPS. So it was basically the navigational satellite time and ranging global positioning system. So the whole world, way back from 1973 till when this whole process was completed way back in 1995. So let me tell you, the idea which was floated in 1973 came to culmination way back in 1995, and then this whole GPS, that is called Navistar GPS, became popular across the world. But it was an idea completely controlled by American agencies. So if the information was there in the public domain, there was certainly always a doubt that if Americans want, they can close the signals in the public domain, and they can even introduce, and they introduced intentionally the error also in the GPS which was there way back in 1995. So from 1995 till 2000, you'll find that this was a phase in which the error-based navigation technology, that is Navistar GPS, was provided to the public, but Americans, they themselves, particularly the Department of Defense, their mariners, their naval forces, their air force, was using the most accurate global positioning system. So what you find that this was completely dominated by the American. So the whole world was almost, in fact, a slave kind of situation where American dominance was very important. As far as India is concerned, very few people were even knowing about it, even in early this 2000. But today, since I have to focus only on the GPS and its application, friends, let me tell you that the idea which was there, which began with the transit NNSS, that is Transit Navy Navigational Satellite System, has become so popular that today it is not only the in the domain of USA, but many more countries and many more unions, they came out with the new systems of GPS, friends. Now look at it. So what you find now, we don't use the word GPS popularly. Now we use the word GNSS system, which means Global Navigational Satellite System. So earlier it was the Navistar GPS, popularly known as GPS, and today we have at the global level Navistar GPS, which is by USA. We have a GLONASS system, which is by Russia. We have Galileo system, which is developed by the European Union. We have BIDU system, which is now the last satellite of the BIDU was launched day before yesterday only by the China. So they have completed their constellation. So they have their 30 satellites in the space. We have Galileo. Again, it has 23 satellites and plus no, it has 27 satellites plus 3 satellites in spare. GLONASS has 23 satellites plus 1 spare. So what do you find that Navistar has 24 satellites plus a few spares. So what do you find that when we started with just 5 satellites at the regional level, and they were placed at a height of about 1,075 kilometers. But all the satellites which are mentioned here, so such as Navistar GPS. So when I say Navistar GPS, it is not one satellite. It is a constellation of as many as 24 satellites to operate at the world level, the entire globe. So Navistar GPS is not single satellite, but it is a constellation, that is group of 24 satellites, all placed at a height of about 22,000 kilometers above the Earth's surface, and in the almost 6 orbital planes. So all around the Earth, in 6 different planes, 4 each satellites are there covering the whole world. So it is a network of satellites from one system. Similarly, GLONASS. GLONASS, I told you, is a satellite system developed by the Russian. So again, they have put the satellites in 3 orbital planes all around the Earth, and their satellites are placed at a height of about 19,000 kilometers with respect to Earth. So while Navistar GPS satellites are at a height of 22,000 kilometers from the Earth, GLONASS satellites are at a height of about 19,000 kilometers with respect to Earth. So Galileo is again the third group of satellites. Again, Galileo has again a set of as many as 30 satellites, and these 30 satellites are again placed in 3 orbital planes. So 6 orbital planes of Navistar GPS, three orbital planes of GLONASS and Galileo. So Galileos are still higher. Galileo's satellites are placed at a height of about 23,000 kilometers with respect to Earth. And then comes Vidhu. Vidhu has not three orbital planes, but they have 10 orbital planes. At one point of time, friends, the Chinese, they were interested to collaborate with the European Union, and for a pretty longer period, they were even financing and supporting the Galileo mission. But then later on, they realized that they can develop their own. So what we find that in the world as on today, we have four global systems. Navistar GPS owned by USA, GLONASS owned by Russia, Galileo owned by European Union, Vidhu owned by China. And then we have at the regional level, we have two important systems which have been developed by countries like India and Japan. So QZSS is a quasi-zenith satellite system, which is a regional GPS system of Japan. And we have Indian regional navigational satellite system, which is developed by India, and popularly it is called as NAVIC also, which stands for Navigation with Indian Constellation. So what you find, the moment you say GPS, it is not once in a satellite, it is always. So in order to have the full coverage of the world, any country, if he wants to develop the global system, then they require at least as many as 24 satellites for one global navigational satellite system. I hope this background must have been shared by the other speaker also. Now, having said this, try to understand that what do we expect when we are talking about the locations. We are looking for the level of accuracy. So if you are navigating from place A to place B, that means you are traveling from place A to place B, normal 100 meter of accuracy is perfect for you. Right? This is very important. So a level of accuracy as expected is 100 meter. But if you are going for mapping purposes, so what you find that the level of accuracy must be very high. So if you want to get the information, then the level of accuracy for the purpose of mapping should be 1 meter. But then if you go more for much more precision work, that means when you are going for geodetic positioning, then the level of accuracy must be in millimeters. So what do you find that we have three important uses of it. One is in the case of navigation, that means the movement on the land, in the air, on the water. So wherever you are moving, then your requirement for navigation is there. And then mapping is another important area. And the third is geodetic positioning, in which the accuracy level is supposed to be high. Now here it is very important for us to understand. First point is that now in the space, as far as GPS or the global position satellites are concerned, there are so many. We are now having more than 108 satellites in all, which are now being used for the purpose of navigation, and they can integrate, they can coordinate, their information can be shared. Now, what is my requirement? Suppose I'm talking to you right now from Chandigarh, and if I'm a user, so the application is dependent on the user. What is my use? How can I use it? Suppose I have a GPS, friends. Now, merely having a GPS is not going to help me in getting the accurate information or accurate data. Now, let me make you understand the basic philosophy, so that it will depend on the user and the way he or she is using the instrument, that the level of precision will be decided. Now, suppose I have a GPS, handheld GPS, and I'm using it. So remember that my handheld GPS as an instrument, it's supposed to be connected with the satellites. And the minimum number of satellites which are there in the space, okay, at a particular point of time, which are visible and always connected to your GPS. The moment you switch on your GPS device, so this GPS device is an instrument which will be directly connected to the satellites. But which satellites? The satellites which are there in the horizon. the satellites which are there exactly above you in this space. So from one horizon to the other horizon, all around you, if you mark a circle, you'll find that the satellites will be there. So all satellites will not be there. So the satellites which are above in this space, exactly above your head or around you, okay, from horizon to horizon level. So if you put a cup format of for the sky, then all those satellites which are there at that particular point of time, they will automatically get connected to your GPS instrument. Is it clear? So what you find? So how many? Suppose you are able to get only one satellite, then your GPS instrument will not operate. If you get two satellites, again your GPS instrument will not operate. If you get three satellites, your GPS instrument will say that this is we have got three satellites, but but with these three satellites, the information which we can be used is in the two-dimensional form. That means the distances from A to B and B to C can be calculated. The third dimension, that is the altitude, cannot be calculated. So what we find here, again, very important issue, that you have to first understand that is my instrument right now connected with one satellite, two satellite, or three satellites. So if we have three satellites connected with my instrument, then I will be getting information only about 2D dimension, two dimensions. That is 2D information. But then if I want the third dimension also, then minimum requirement of satellite for me is four. Four satellites are required to be connected with my instrument, which can be displayed. Which, all this information is displayed on the instrument itself. So you can see how many satellites have been connected. But suppose you have got the four satellites, but these four satellites are located at the level of horizon. I hope you understand the meaning of horizon. Horizon is an apparent position of Earth and the sky. So it appears that Earth and sky are meeting. So the point where you feel that Earth and sky are meeting, that is called as horizon. So if your satellites are at the level of horizon, which you can see on the screen of your instrument, remember that these signals which will be received from those satellites to your instrument will be obstructed very badly, because from that horizon point to your instrument there will be forest, there will be big buildings, there may be a mountain, and consequent to which when the signal has to come, the signal will be very badly obstructed, and therefore the quality of information which you are going to get will be very poor, and that has to be kept. So what you find, that even if you have satellites connected with your instrument, if the number of satellites connected are four, but their position is at such a location that from there the signals are very poor, you will not be able to use it correctly, because there will be huge amount of error. Number two, suppose your satellites are vertically above you. Remember, here is a catchword. So what you find, that if you can see it on the screen, that the satellites are located vertically above you, that means the signals are reaching you very strong. So you can see the strength of signals in the instrument. You can see the strength. So in place of having the reservations that you are not getting the uh, uh, signals, you can see yourself the strength of signals. The length of signals, or the highest bar or the longest bar, indicates that the signal strengths are very accurate. So what you find, that you have to decide when do you want to use this instrument, when the satellites are in the vertical position with respect to you, or when they are at the horizontal position. Remember here, if you take a wrong decision, obviously the level of accuracy will go down. That is very important. Number one. Number two, why then when you want to use the instruments, it is not merely purchasing the instrument, friends. Two important things are to be adjusted every time. Suppose you are working in India, then you have to adjust your instrument, okay, and therefore what is done, that you have to manage a few things in your instrument. That means you have to fix your compass yourself. That means if you don't fix your compass as per your requirement, at the same time the instrument will ask you the altimeter or the altitude of that place. So if you do not have this information, the system on its own will work. And then there is always a possibility of some error because you are working at a particular place and the system has some information. So, so if you want to be very precise, you have to give the information yourself in the instrument. You have to feed the information. Similarly, the unit has to be fed by you. So what if I find that these are the preliminary information which you have to feed initially when you start your work with the GPS instrument. Once you have done it, then you find that the level of accuracy will improve. But here again, there are some things to be kept in mind very carefully. Number one, so what you find that you have an instrument and you want to work on it, but what you find that the information or the instrument which you have purchased has the ability to capture only single frequency. So we have instruments available which can catch only single frequency, but we do have systems available in the market which can catch the dual frequency. So a person with single frequency and GPS and a person with dual frequency GPS will certainly have different amount of error. The one who is using dual frequency will have a high level of accuracy. The one who is using single frequency will have a low level of accuracy. That is also equally important. At the same time, what you find that some of the signals are not available to the public. That means a very high level precision. So what you find for the public, the standard positioning system is there. But then when it comes to precision or precise positioning system, the precise positioning system in the whole world is used only by the defense forces. Whether it is USA, whether it is Russia, whether it is India. So what you find that precise positioning will not be made to public for their normal uses, but only defense forces will be used where you'll find that their level of accuracy is in millimeters. But for common people, the instruments are not sold. If you want to purchase those high quality instruments which can give you the millimeter or sub-millimeter level accuracy, remember, no country will allow you unless you are part of their defense system, unless you are part of their navigation or aviation system. So if you are part of them, then all this information is given to you. But if you are a common man will be given only single level frequency information. But then the moment you are part of DRDO in India or DOD in USA or in the Russian secret agencies, then the information is available. So 3 points must be very clear to you that the level of accuracy, even if you want to get from the commercial uses, the level of accuracy will not be given to you, which is there in the precise positioning system, but only the standard positioning system, because that is what is operating. So what do you find? The accuracy of the GPS signal in space is actually the same for both the civilian GPS services, that is SPS, and the military. But GPS services, that is the PPS, however, SPS broadcasts one frequency. That is what I told you, right? That is standard positioning system broadcasts on one frequency, while PPS uses two. This means military users can perform ionospheric corrections, a technique that reduces radio degradation caused by the Earth's atmosphere. With less degradation, PPS provides better accuracy than the basic SPS. So standard positioning system has relatively less level of accuracy. Now, coming to the application of GPS technology. Let me tell you, friends, that see, people purchase a GPS instrument. It is like purchasing a computer, right? Now, what I have seen that people purchase computers, but the total possibility which a computer can do for you Not even 1% is used by a common man. For common man, it is used for either entertainment or for seeing something on the internet. But that is not the only purpose of a computer. Computer can do wonders depending on how creatively you use it. And if you don't use it, if you misuse it, then you become slave of the system. Similarly, in case of GPS also, we have to be very careful, and we have to understand and comprehend the whole situation, that if I have an instrument, what kind of information this gives me. Let us try to recollect and recall first. So your GPS will give you information of your location in terms of latitude, longitude, altitude. So remember it. So what do you get? You get three information. Your location in terms of latitude, longitude, altitude. So wherever you are on the earth, your position can be determined very precisely. Let me tell you, unless GPS was invented, nobody in the world on a small scale map was in a position to identify the locations in degrees, minutes, and seconds. The best cartographers in the world, when they were trying to locate and precisely point out the position of a point, let me tell you, they could not go beyond degrees and minutes. Today, what we find that one can very, very precisely identify the location of a person in terms of the degrees, minutes, and seconds. And here again, you have to understand that when I'm saying these degrees, minutes, and seconds, they are not to be understood very easily, because again catchword has to be understood. Now let me tell you, suppose there is a difference of 1 degree of longitudinal distance. That means place A and place B has a difference of 1 degree longitude. Where? At the equator, suppose equator. Now this particular 1 degree of longitude has a ground distance of about 111 kilometer. So when you say that there was a difference of 1 degree of error, now 1 degree of error at the point of equator means an error of 111 kilometer, which is too far. Which is too far. Similarly, when it comes to the minutes level or seconds level, it is not that simple, because when we are talking in terms of degrees, minutes, and seconds, the distances to be covered by even a second arc of the on the earth is again a huge distance, and that has to be kept in mind. And therefore, so what do you find that you get the information in terms of latitude, longitude, and here the most important point is that has to be learned by everybody, that this gives every place an unique identity. And how? The basic principle is that no two places will have the same latitude and longitude. So each place on the earth has a unique latitude and longitude. Again, to make things more simple, two places may have same latitude, but they may not be having same longitude. Two places may have a same longitude, but they may not have the same latitude. That means, in simple words, the identity which is given to every point on the earth is to be very, very different. So they will differ in terms of degrees, minutes, and seconds. So every point on the earth has a unique geocoding. Again, remember it, that every point on the earth can be given an identity in terms of its geocoding. First information. Remember, friends, this is the basic information with you. So you come to know about latitude, longitude, and altitude. That means height. Here you have to be very careful that the height which you are getting in your system is with reference to the mean sea level, or you are getting the with reference to the Earth center. This is very important. Let me tell you here that the height, the altitude which is determined here is with reference to the mean sea level of a country. If you have to set it, But if you have not done that, then in that case, the system automatically will take the Earth as a center. So all calculations in the celestial world, that means in the space, are not with respect to the mean sea level of the Earth, but with respect to the center of the Earth. So one planet and the other planet and their distances are to be calculated not with reference to mean sea level, but with reference to the center of the Earth and center of that planet. Otherwise, if you go by the surface confusion of the Earth, then it is going to be complete confusion. And therefore, what we find that in case of GPS, we take the center of the Earth so that the calculations are correct. Third point, the time. Let me tell you again, the time which you use is again the human creation. Because if you are in the outer space, let me tell you, the days, months, years are not there. So what you do, you have your own time. The time which you follow is the time which is followed by the human beings on the earth, and therefore we want this time to be understood in as precisely as possible. And therefore, friends, in the system we get the time from atomic clocks. That means very very precise. So up to milliseconds of the time we get the accurate information. And if you're using this GPS, let me tell you, the whole world is connected with satellites. So all the satellites will be using the same atomic clock, which is very, very important. So what do you get now? Now you have latitude, you have longitude, you have altitude, you have the exact time, and then you have the geocentric position, and then look at it. So time is also there with you. You got time also. What else? You also get the information about the moon set. You will get the time about the sunset, sunrise. All such information is provided to you. At the same time, when you are moving from place A to place B, the total distance covered by you can be seen on the screen. Very interesting. Number one. Number two, the total time required to cover a particular distance at a particular speed. So speed and the time, they are connected to each other, through which one can easily identify the velocity of the moving objects. So what you find, that the system is also giving you the speed at which you are moving. The system is also giving you the time from when you started and when you are to reach. And suppose you have identified a place which is far away from you, you want to reach that place, the system will be guiding you regularly that this particular place is this much distance away from you, and if you want to reach that place, you have to increase the speed or you have to decrease the speed. All decisions are to be taken by you. At the same time, if you want to develop further, and if you want to determine the positions of new things on the way, you just for the purpose of surveying. So earlier we used to carry a lot of instrument for survey. Now no instrument is required. You just go with GPS and then go on marking waymarks. So we call them as waypoints. So whatever you want to find out on the way, suppose you have done a survey 5 years back, if you do the same survey next after 5 years, you find that maybe so many things which have changed, new things have come out, many old things are no more there. So what you do? You can again reconstruct the latest map for yourself, and then all outdated information will be deleted. And that is how the whole GPS technology operates for you. So as far as the application is concerned, first is relates to with location. And what does it mean? Determining a basic position. This is very important. Number two, navigation, getting from one location to. So most of you now in 2020 are aware that in most of your vehicles or even your mobile phones, you can navigate from place A to place B very easily. That is not a problem because you can see the path, you can see the locations, you can see the roads, and that helps you. That helps you. And remember here again that the information which is coming to you is again translated in the form of an image, and this is done on the ground by you. Okay, human beings do it. Okay, the using cement does it. So then we identify the roads, we identify the streets, we identify the buildings, and we give them the labels. So who is doing the labeling? Satellite is not doing any labeling for you. Satellite is giving you only the precise position of the things, and they are to be recorded. They are to be recorded by you, they are to be entered. So the input data has to come from you. The input data has to be there from you. The user will be putting inputs. So if you keep on putting the inputs, you will be able to use it. Remember, satellite will not be giving you input. Satellite will help you in determining the position in terms of latitude, longitude, altitude. But what is the name of that object? You have to feed. What is the name of that road? You have to feed. Okay, what colors you want to introduce, you have to feed. What symbols you want to do, you have to feed. That means the whole mapping, the basic philosophy of mapping is to be done by the user itself. Again, let me tell you, GPS technology will not give you all this socio-economic information which is there on the earth. Okay, so it can give you only the precise position if you press the button for waypoint. So the moment you press the button, it will give you the location in terms of latitude, longitudes, altitude. It will record the time, at what time this was done, on what date it was done, at what day it was done, in which year it was done. That is all given to you. So you can use that. Again, repeat you that if all such information is there, how can you use this information? Depends on your own intelligence. That is very, very important, friends. That is very, very important. Now, so friends, let me tell you that those who are using a mobile phone which is Android system, or those who are using a mobile phone which has iPhone, okay, let me tell you, whether you have internet or whether you don't have internet, your position, your locations are known. Right? Here it is very important for you. Your position and locations are known to the service providers. So suppose you are using the Airtel, you are using the BSNL, or you are using any technology or any service by any agency, your location, your movements are known, particularly in those two systems where we have iPhone and we have Android system. That is why, friends, when you cross from one zone to the other zone, okay, you start getting the information that you are now in Delhi, or you are in other place, you are in Israel, or you are, that is there. So internet is not required. Internet is not required in the Android system. Internet is not required in the case of the iPhones, because they have the ability, they can track your locations and they record the locations. So suppose you want to know that in the last 1 year, which different places you have visited, the mobile users will and their locations will be marked very precisely that on this particular day you are there in this particular city, and within that city from which point to which point you have moved, to the extent that at what time you are at what location. Look at it. If this information is there, again you have to apply your mind that how can I use this information, how can I use this information. Okay, remember, friends, in the name of privacy, your locational data is not made public. But whenever there is a requirement by the government, your positional data, your locational data can be used for the purpose of security of the nation. So remember, all mobile users, now their information is there in the public, they are in with the government, with the service providers, but that is not made public. I remember I asked my students in the class that would you like your locations to be known to your mother when you are in the university system? And the one common answer by all the students was no. That means you do not want to reveal your actual position to your parents. And therefore, when they call you and where are you, and if even if you are watching a movie, you will say I'm attending a class of GPS which is online. Now this is fun. That means you are giving a wrong information. You are giving a wrong information to parents. Now this technology is not meant for the wrong information. This technology is meant for right information. So the information is there, but it is not being shared. The moment your parents want this information, because they have some idea that my child is doing something wrong, they can certainly get access by requesting to the government, and government will provide you the information about all your locations. The service providers have been asked to record and keep them with them. That is there. So third point is there, and that is the tracking. So if you want to track something, that is monitoring the movement of people and things. I told you the example itself that if you want to track, so if you want to track the trucks, if you want to track the buses, if you want to track the pizza hut pizza delivery boys, if you want to track the movements of the goods or the movement of trains, the movement of aeroplanes in the sky, and then you find that yes, everything is possible. So you are able to see. Remember, for the last 6 years, in the government, even in India, if you want to see about the movement of trains on the screen, you can see at this particular point of time where is this train standing and at what time, or it is on the way. Similarly, you can see in your sky on the screen that which particular plane is there and where they are moving, and all such information is there now available on the screen. It is all possible because now we have the GPS technology, and this is going to provide us all the movements in the sky, in the air, on the land, on the water, under the water. Everything is possible, and that is very, very important. So now, again, the use will depend on your intelligence. So we then mapping, creating maps of the world. So I told you yesterday also that we have photogrammetry, we have remote sensing, you get the information. But then what you find that using a GPS technology, the actual geolocations are possible for us to get, right? So if you are in Hyderabad, for example, and if within the Hyderabad you are moving from place A to place B, and then you are interested to know how many new chemist shops have emerged in the town. So you just move on the road, wherever you find a chemist shop, just press the button. Its information will be recorded in terms of latitude, longitude, and altitude. Then you add the labels to it that this was this particular point, and you have created a map for it. Then you move further, and then you find another shop, third shop, fourth shop. So you can complete the survey by evening by moving in the vehicle itself, and you have by the end the complete information. In what terms? You get the inventory of the total chemist shops. You also get the map in the world format, and then you can see that these are the places which you have visited, and the maps are ready. Now, no other system can prepare maps so quickly for you because the routes which you followed is automatically mapped. The buttons which you pressed were automatically given a label by the system which you can edit and create your own maps. So what you find that this GPS is helping you in surveying, and this GPS is helping you to provide the almost near real-time maps. Near real-time maps, and that is the wonderful achievement of this particular technology. Next, timing, bringing precise timing to the world. Friends, what do you find that in the traditional mode, if something is happening at a particular point of time, after some time we forget about it. But then what we find that in this particular system, everything is recorded in terms of time. This incident happened on what date, at what time, okay, on in which particular year is all recorded. And this can be used after 2 years by yourself, by somebody else, by third person in India, outside India. Anybody can use that information because the recording is automatically. You are not doing any this feeding part of it. Input is automatically coming, and therefore this is going to be of great use. Now, let us look at the some more applications. If that the background is clear to you. So what do you find? That GPS technology is now in everything from cell phones and wristwatches to bulldozers, shipping containers, and ATMs. So everywhere we are. So see, the application is emerging more and more. And look at it. GPS boosts productivity across a wide swath of the economy to include farming. In Israel, I was there in Israel and I found that farmers are using the GPS, construction, mining, surveying, package delivery, and logistical supply chain management. Everywhere this is used. Major communication networks, banking systems, financial markets, and power grids depend heavily on GPS for precise time synchronization. Some wireless services cannot operate without it. That is the beauty of the whole technologies. Look at the dependence. GPS saves lives by preventing transportation accidents, aiding search and rescue efforts, and speeding the delivery of emergency services and disaster relief. Look at the uses. See, think of its possible use, and you'll find that it is going to help you. GPS is vital for the next generation air transportation systems. Remember, friends, in Delhi particularly, or in North India, we find that during the month of January or December, because of fog, in large number of airports except Delhi, we find that landing is not possible because of poor visibility. But this problem is not there at Indira Gandhi International Airport at Terminal 3. Why? Because at that particular place they have the high quality GPS enabled system, in which if the plane is having a GPS enabled system, the pilot has nothing to do but it has to put in the auto mode, and it will be very precisely landing at the given latitude, longitudes, and the altitude very precisely in minutes, degrees, and seconds. So if your runway is clear, or if on the runway there is no vehicle or no animal, then there is no possibility of accident, because the pilot has fed the system and he can see on the screen. Even if the visibility on the in his through his eyes are not there, he will be landing the flight without any trouble. But that is not there everywhere. So what we find that once the system is there, so it is not necessary to see things, but you have to see it on the screen only. And even if it is dense fog, landing of the flight will not be problem, because the actual geo codes or geo coordinates are given. Once the geo coordinates are given very precisely, the flight will not be having any difficulty in the movement. And that is the beauty of the whole system. So GPS also advances scientific aims such as weather forecasting, earthquake monitoring, and environmental protection. So what do you find? I have listed so many uses where one can use the technology. People are now using it for private and recreation. Very interesting. Now, if they are traveling by car, they use it. Hiking, climbing, and biking. Vehicle control, mapping, survey, and geology. Agriculture, aviation, general and commercial purposes, both. Spacecraft, maritime, more. Store locators, using location-based intelligence, retail customers can quickly find the nearest store locations. Proximity-based marketing, local companies can push ads only to individuals within the same geographic location. Location-based mobile marketing delivers ads to potential customers within that city who might actually act on the information. Travel information, and so the local service provider can deliver real-time information such as traffic updates or the weather reports to the smartphones to use, and this can be used. Roadside assistance, in the event of a blown tire or accident, many roadside assistance companies provide an app that allows them to track your exact location without the need of giving directions. A few more. Mobile workforce management, for logistic dependent companies that employ individuals out in the field or at multiple locations, and LBS allows the employees to check in at a location using their mobile device. Fraud preventions, and LBS creates another level of security by matching a customer's location to the smartphone to a credit card transaction. Trying a smartphone can help. We have more. A GPS can help you locate a lost child. This is also happening because the child is given a GPS. So where is the child? Available in some of the European countries, but even in USA, people are using it. Particularly when they go to a market or far off place, and if the child is lost, child can be easily located. People are even using it for the lost pet. If the pest is lost, pest is given the GPS instrument, and then one can easily identify. When working in conjunction with your cell phone, a GPS can allow you to call for assistance from anywhere. Your location can be tracked. So if you are using it, people are also using this technology, friends, for exercise monitor. I told you that at what speed you are moving can be shown. So if you have a GPS, and if you are moving or walking, then you can see at what speed you are moving. So if a doctor has advised you to walk 1 kilometer in 15 minutes, and then if you're walking faster than that, maybe you are a heart patient, then you can see, okay, my speed is more. Or so looking at the GPS instrument itself, you can manage your speed. And then so people are using it for exercise monitor also. So what do you find, that there are so many ways in which this technology can be used. But then 2 points more. Now the security issue, if GPS is giving you so many information so precisely, can it be used by the enemies, or can it be used wrong also? And therefore what we find, that we have something called as the GPS dots. That means if you want that your information is not made public, because your building is very strategic, your ordnance factories are there, your airports are there, and you don't want that people in a particular range can get the very precise information, because we have warheads available. So what do we do? We can befool it by having a wave bubble. It is a kind of jamming device. So people around it in a particular zone will not be able to get the correct information. You can introduce an error, and your location will be wrongly informed. That is also called as GPS spoofer. So in the GPS spoofer also, you can create a situation where the most strategic locations, such as the president house or prime minister residence, so if you want to save them, so the moment you go with your GPS will give you the information, but that information will be full of errors. So security issues are also there, and therefore this can be done again by the user only. Satellite will be giving you the information. Satellite will not discriminate the information, but as a user on the ground segment itself. So the people around a particular location have this facility that they can work with the signals, and all the instruments in that area which is being used, they will be giving errors, a lot of errors, and then the exact and precise locations cannot be used by the enemies. That is very important, friends. Now, since you're all engineers, now you have to define your role. In the case of application, first, innovate and develop more and more applications of GPS. So depending on your requirement, friends, you can think of in what way I can use this GPS. Depends on your requirement. Number two, ensure to record the changes in locations and emergence of new features using GPS after regular interval of time. So if wherever you are, if you want to keep a record of what changes have taken place, maybe because in the absence of changes, friends, we do not have the past. Today, if you start recording the information regularly of a particular place, how things changed, then after 10 years, the change detection in a particular place will be very easy, which is not normally done. And the third, our regional, so India has Indian Regional Navigational Satellite System. All the engineers, all the scientists who are listening to me, I have a small request that try and think that when will India become and provide a global navigation status? Because that is very important. Right now, we are managing with only 7 satellites. 3 of them are in the geostationary position. 4 of them are in the geosynchronous position. And we are in a position to operate it at a regional level where China, Pakistan, and some part of Turkey, Iran and Iraq and Sri Lanka, Bangladesh, they can be covered. But we do not have a global system like our Navistar GPS or GLONASS or Galileo or Vidu, which is with China. So today we have a regional system with us. Tomorrow, I wish that people like you can think of making and providing an Indian system also a global status. Thank you, friends. Thank you very much.
Thank you very much, Professor Mohan. Now, I would request all the participants that if they've got any question,
Yes,
either you can switch on your microphones, or maybe
I'll
you
be very
can
happy.
put in your question in the chat box.
I will be very happy to answer their questions.
Prasad, I think there are one or two questions in the chat box. अगर आप,
Okay.
one
Monica
is
can read
from
them
Mr.
for me. Monica, please read them for me.
One is from Mr. Kapil Ori.
Yes.
जीपीएस इज बेस्ड अपॉन ट्रू मेरिडियन और विद रिस्पेक्ट टू अर्थ नहीं है तो उन्होंने रिप्लाई किया वैसे किसी जीपीएस
Uh-huh.
प्रेजेंट पोजीशन जीपीएस इज बेस्ड अपॉन द ट्रू मेरिडियन और विद रिस्पेक्ट टू आवर प्रेजेंट पोजीशन सर आपने पहले क्वेश्चन पूछा होगा उनका रिप्लाई दे
Uh-huh.
क्वेश्चन फ्रॉम एनी पार्टिसिपेंट so how atomic clock works how
Very good
atomic
question.
clock works
See, atomic clock is a very, very precise clock. So what happens in the case of atomic clock? That see, in our watches we talk about hours, minutes, and seconds. In the atomic clock, the timings are very, very precise, even in the milliseconds. Okay, some milliseconds. So that the timing of place A and place B, okay, can be managed. So the problem is that if you want to calculate the distance between point A and point B, now the distance is always related with the time. So in case of the GPS, what happens? The GPS operates with the help of radio signals. So we have to calculate the with the help of radio signals, the time taken by the radio signals to travel from point A to point B will be converted into the form of distance. So if we do not have a very precise atomic clock or the clock, then even there is a difference of 1 second, or and that 1 second will have a huge difference. Therefore, we require a clock which operates in the most accurate manner, friends. Let me tell you here that, for example, when you were in schools, you were taught about that Earth takes 365 days to complete one rotation, and in the leap year it takes 366 days. Now, all these are related to human beings. We have converted them, we have decided them. In the actual situation, it is not there. So, if you have a clock which the clock will be managed in such a manner that not even a second of difference is there, and therefore this atomic clock is very, very important. Yes.
sir does GPS work underwater
Yes, it can work. Yes, 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 yes. It works underwater also.
where is the mean sea level reference for India or is it the same worldwide
What is the question? Again, read it.
where is the mean sea level reference
Yes,
for
yes.
India
Good question. See,
or
first of all, try to understand what is mean sea level. We are using the mean. Mean is the average, and sea level. That means we have the high tide position, we have the low tide position. But this high tide position and the low tide positions at different places are going to vary. When the British were with us, they used to have the mean sea level with reference to the Chennai coast. Now, okay, so the average was calculated of the high tide position and the low tide position, and that becomes the reference point in case of India. But remember that it can't be used for the whole world.
There is one question by Geeta Bhatia. In level of
Yes.
accuracy, what is geodetic positioning?
Good question. See, friends, when you are on the earth, every day you get a feeling that suppose you move from place A to place B in a flat plane surface, you don't get the idea about the curve. Okay, but your earth is not flat surface. Your earth is a curve. The moment we talk about the curve of the earth, then it becomes the part of the geodesy. Okay, geodesy. So suppose you are an engineer and you want to lay down the cable or wire from place A to place B. Now on the ground, friends, remember that if you have the electrical poles of the same height, and if you try to put them on the ground, you will find it very difficult, because all the poles, if they are of the same height, then after some distance you'll find that they are not at the same height. Why? Because of the curve of the earth. So what you find that on the one side of the curve and the other side of the curve, you'll find that there is going to be a lot of difference. So ultimately, it is the curve which matters for you, and therefore, when we talk about the geodesy, it is the curvature of the Earth. So calculating the curvature of the Earth is very, very important. Earth is not a flat surface. Therefore, if you're standing at any part of the Earth, you cannot see the other person beyond the horizon, because the point of horizon is nothing but it is just an apparent feeling, because the person beyond that will not be visible to you, because that's the curve part of it. At the curve part of it. So geodesy is basically related with the science of the Earth's curvature.
There's a question by Sibba Nayak.
How long?
How low internet connectivity factor is taken care of in areas so far as GPS application is concerned?
Internet, no, see, internet has nothing to do. See, what happens if you have GPS, the information of the GPS is linked with internet for your purpose. Okay, so see, the GPS instrument has nothing to do with internet, but now the GPS instruments which are coming, they are internet enabled. That means you can connect that. So why so? So what you find that if you are using the GPS, the information which you collect or use can be easily transferred from place A to place B with the help of internet. So the transfer of information from place A to place is enabled by the use of internet. Otherwise, internet has nothing to do with the GPS information which is collected directly from satellite. Remember, internet is regulated and governed by the ground segment or the service providers, whereas GPS is directly getting information from the satellite. And therefore, if you have a GPS, remember, GPS information is not governed by any country. GPS information is directly coming from the satellite. Yes.
There's another question by Karan. When were the entity's location, extent, or attributes measured?
No, see, it depends on you. Whatever you want to measure, see, the first, see, let us first define our requirement. Suppose I am owner of 20 buses, okay, and I want that my drivers are always in giving me the right information. So I enabled all my buses with the GPS instrument. Now my driver cannot do anything. Now the when this what route is being followed by my driver is visible to me, what at what point he stopped and for what time he stopped is known to me, and therefore I can track all his movements. So as far as the recording of information is concerned, one can easily do it. Only issue is that suppose you are working for the defense services, okay, and you want to be very precise. In that situation, you require the high quality GPS instruments, precision level. But then for common navigation, the kind of GPS which are available in the market can be used. So the recording of information is completely dependent on the user and his objective with which he wants to work.
Now, next question is from Joachim. With reference to mean sea level, how we state the height of place, say Mount Everest?
With reference to?
With reference to mean sea level, yeah.
Joachim, it is very simple. So what we see for the calculation of altitude on the Earth, human beings our predecessors decided that we require a reference level. So this mean sea level is considered to be 0. Okay, and with that reference level, when you move to the other places, everything above this 0 will be called as above mean sea level, and anything below this will be called as below mean sea level. So this mean sea level is just a reference point and an arbitrary value. It is not scientific. It is a method of operating on the Earth. Remember it. So what we have done, we took the mean sea level at a particular point of time, but let me tell you that this mean sea level cannot be constant forever. It is going to change. Therefore, when you are working for very precise, then you will not believe and you will not going to use this as the reference point. And therefore, in the GPS particularly, when we thought of about it, it was decided that in place of taking the mean sea level, let us take the center of the Earth, particularly when you are operating between interplanetary distances. So
Right.
this sea level is a arbitrary reference for common
So,
man.
sir, the height of the Everest, say, mean sea level varies for different countries. That's what I understand from your earlier
Yes, yes,
answer. Yes.
very true, very true. It depends from where do you calculate.
So we say Everest is 8 kilometers tall. 8.8 kilometers tall means it is with reference to some value
Yes,
set by Nepal, probably.
with reference to our mean sea level from Chennai.
Right, sir. Thanks, sir.
Okay, good.
Okay, Doctor Saab, thank you so much. I believe there are no questions further on. So
Okay.
I think you can exit now.
So
Thank you
friends,
so much
the
for
last,
your wonderful presentation.
let me have a minute.
Please,
So
please do.
friends, see, I interacted with you for the last 4 days, but let me tell you, I have been able to provide you